folks. Welcome to Rational Science. We're going to be talking about dark photons today, whatever those are. But before we do, I'm going to tie some loose ends. We were talking about electricity the other day, and some things have not been put out there, so I want to talk a little bit about them. Let me start here with the quantum atom, okay? And that's the atom that we have today from quantum mechanics. And what you see there is a little electron blue ball going around the nucleus. And this is more or less the atom we have today, okay? And what's the problem with this atom? Well, this atom has several problems, but I'm going to mention the most important ones for the lecture today, and that is that the electron ball, as you can see, does not fall towards the nucleus or spontaneously fly away. Okay, and so the question is, whoever presents this type of atom has to explain why the electron bead does not fall to the nucleus or fly away spontaneously. And until that is answered, we don't have an atom with which to begin the presentation. Okay, so this is the problem with quantum mechanics. They're atom, okay, for the purposes of electricity. And what's the issue? The issue is that because they use this atom to explain electricity, we end up with this version of electricity. And you can see that the electron beads are just flying from atom to atom, right? And that's the notion that we have today of electricity. This is what is taught in high school and in college. And the question is whether this is a valid version of electricity, the electron beads flowing from atom to atom. Turns out that they've gone a step further and they've gotten rid of the atom altogether. Okay, so now they have this. They have the electron beads just moving from atom to atom, and now they've taken the atom out of there, the nucleus, right? And they only have the electron beads. So electricity is simply the flow of electron beads, negative beads that go to the positive pole, in this case of a vacuum chamber. And so the question is whether that is, how Mother Nature runs her shop. Is this a faithful reflection of electricity? That's the question. And yeah, we have a problem because, we have these electron beads. There's no reason for them to be moving towards a positive pole. It's just a description. The theorists say they just do. Okay, that's it. There's no reason, no cause. Okay, they just said they do. Okay, so this is part of the problem. There's no explanation. It's just a description, usually a mathematical description, and they have no justification for it. Okay, so here we have a circuit, okay, and that's what it looks like. Essentially, all the electron beads, the red ones there, they go around to the positive pole, right, of a battery, and they come out of the negative pole. So they have all these electron beads going around. Supposedly, the atoms are in place. They don't move. It's just the electron beads that go around, okay? That's apparently what they propose. If someone proposes something different, please let me know, okay? And based on this model of electricity, we had good old Albert Einstein, who in 1905 wrote about the photoelectric effect, for which he would win the Nobel Prize in 1921, and that is that light, a bunch of particles also, discrete particles, hits a polished metal surface, and what it does, it compels, it hits, right, the electron beads, the blue ones there, and forces them to move, and that movement of those electron beads is what we call electricity. So the issue here is that all the way till the beginning of the 20th century, we had these notions that both were light as well as electrons are just beads. And the question is whether this has any merit whatsoever. Is this a faithful model of what Mother Nature has out there, or is this totally off the wall? Okay, what do we propose instead? Just so we have a point of comparison, this is our atom, and you can see the electron is a membrane, that red one there, that encapsulates the proton star, which is the nucleus. Okay, so we have this encapsulating shell, membrane, balloon, and what you see is all the ropes where that convey light converging upon our atom. One thread goes through the center and the other one goes around. The red one in this case, right, just color-coded so that we can make sense of this. The red one goes around and builds the electron shell, okay? And the other one goes straight to the center and builds the proton star. That's it. That's the model. Very simple atom. That's the one we say is the one Mother Nature has. And you might say, well, where did you get this idea that the electron is a ball, a shell, a balloon, a membrane that encapsulates the proton? Well, here I've taken some videos, little clips that show you how teachers explain these things in the classroom, okay? And what you will see here is that they have these balloons with which they represent the orbitals, supposedly, of what the electron is, okay? And just look at it, it's visual only. Here it goes. These are the p orbitals, and you can see the lady here, she's representing them with balloons. Here's another fellow, and he represents them with balloons. Okay, those are the orbitals, and that's what they look like. And here you have another fellow, he just puts these balloons there. So yeah, this is what people think the orbitals are. They are balloons. And so we're not that far off when we say that, yeah, the electron is a balloon, okay? So, this is what we're proposing. Nothing has changed. Essentially, we're in line with chemistry, saying that, these electrons, not a little bead that moves around. It's a balloon that encapsulates. Now we have a physical object. The bead, in fact, is not even a thing because it's supposedly a point particle, no shape, no size, okay? They say they can't measure that deep, something so small, and so they essentially considered it a point particle, one that has no structure. And again, they're doing physics with non-entities. That's what it ends up being. That's the reality. That's how they explain their theories. Okay, so if the electron is a shell, a balloon, a membrane, right? Not a little bead. Here's our iron atom. Okay, and that's I put iron there because it's a conductor, and that's what we're going to be using primarily for electricity. If you put several iron atoms, like you see there in the center, it builds, these molecules, right, that are all merged with each other. And at the bottom, you see a full strip of these molecules, right, or atoms turned in, that are merged with other atoms, forming molecules, forming these long strips, okay? And what are we going to do with this? Well, here, let me put it in a dynamic mode, okay? Here we see the atom there, again, iron atom, and they form these long strips, and the whole strip, this whole, you can call them serpentines, right, twirls in situ. Okay, it just turns around in situ. Okay, that's going to be electricity. In other words, electricity is not a motion of a little bead that goes from left to right. Electricity is the torsion of merged molecules, long strip of molecules, right, inside the wire, right, the metal, or this is iron in this case, and they're twirling in situ, okay? But they twirl in a given way, and here let me illustrate that so that you can compare the official version against what we're proposing. Okay, here we have at the top we have the electron beads moving all around the circuit, and what we're saying is nothing moves around the circuit. What you have is in situ torsions of these molecules, right? and it's like it's twisted. In other words, it's like a spiral all around the circuit. Okay, so that's what we're proposing is electricity. And yes, you cannot do, under our model, you cannot do electricity without atoms, without merged atoms. In fact, they have to be connected. They all have to be connected as a series, right? And they twirl in situ in a spiraling motion. So they go like this, more or less. And yeah, Mother Nature doesn't understand positive or negative. Mother Nature understands clockwise and counterclockwise, okay? Because Mother Nature just moves objects around every day. She works with objects. She never went to school. She doesn't know anything about math, okay? So you can't tell her, look, this is positive and that's negative. This is North Pole, this is South Pole, because she doesn't understand what that is, okay? We've invented those labels, and those labels have no physical interpretation. We are now giving a physical interpretation. We're saying all these years they've been talking about clockwise and counterclockwise. And of course, if you take any elongated entity and you twirl it, right, from your end it goes, for example, right now I'm looking at it from my point of view, it's going clockwise. From your point of view, it's going counterclockwise, right? And at the other end, hopefully the opposite is true. So if it's going clockwise here, it's going counterclockwise over there, or vice versa, right? So that explains why, we have two poles, positive and negative. One is clockwise, the other end had better be counterclockwise, okay, or vice versa. Okay, and here we can see with magnets, okay, this is our version of magnets, okay, you have positive versus negative. In other words, you have North Pole versus South Pole. When you put two poles together, like in this case, we put blue against blue, whatever that is, north, north, south, south, whatever, you can see why the threads that swing around push each other away. They attract each other when they both are clockwise at the top, counterclockwise at the bottom, or vice versa, right? When you turn them around, you have clockwise versus counterclockwise, and now they push each other away. Okay, so the mechanism is there. A field is made of lines of force. The lines of force are real. They are threads of the ropes that are swinging around. Okay, so that's our version of magnetism, and it's got to do with clockwise, counterclockwise. And people say, well, Bill, where'd you get this crazy idea that a field is made of real lines of force, and those real lines of force are actually threads from the ropes and from the atoms? And here's a good evidence for those who want to be convinced through evidence, okay? We don't do that in science, we just conceptualize, but people want evidence and proof and whatever. And here it is, you can see this is a magnet that's underwater, and it's in very, very slow motion. But what you can see is that all the iron filings, as soon as they put the magnet in there, inside that little tube, as soon as they put that magnet in there, all the iron filings are gradually, you can see it's a gradual thing, right? Gradually approaching the magnet. Something is moving in that region and pulling all these little iron filings towards the magnet. And what we're saying is what we have there is an invisible field. What is the field made out of? Lines of force. Those lines of force are threads that are swinging around, pulling the iron's filings towards the magnet. Okay, so we have a reason to propose this as a hypothesis that what you have is ropes, atoms, and the swinging around of these threads, not ropes, but the threads, right? People confuse the thread with the rope. These are two different things. The threads swing around. When they swing around, if they hit each other, right, they push each other away. If they go in the same direction, both of them clockwise or counterclockwise, then as one comes down, the other one comes up and pulls. So we have attraction and we have repulsion. That's it. That's how simple Mother Nature is. That's how simple magnetism is. Now, there's a group of people who, there's really several groups of people out there, but one that I'm going to talk about today are the electric universe. The electric universe are electricians. They favor electricity over gravity. In other words, they say that gravity is electricity and has nothing to do, or very little to do, if anything, right, with mass. In other words, they don't like Newton's mass times mass equation. They would rather go with the electric equation that essentially is a copy of Newton's equation. Okay, you have charges instead of masses. And what's the issue there? These electric universe people, what they do is they try to explain everything in the universe through electricity. They say everything in the universe is electricity. Well, they almost got that right. It's not electricity, it's magnetism. And people say, well, Bill, but you can't have magnetism without electricity, right? Yeah, absolutely. But we have to put it in the right context. There is no electricity flowing from star to star throughout space or from galaxy to galaxy. And that's where we run into trouble. These people want to build a universe in which electricity serves as the mediator between planets and stars. In fact, it's that electricity, according to them, that powers the stars and gives them all these properties like the plasma around the star, etc., right? We're saying it's got nothing to do with electricity. Electricity is local, only local, because again, little atoms, little electrons don't travel through space with or without atoms, but it turns out that there are no atoms out there in space. So even if the electrons had to move from one star to another or a galaxy to another, they wouldn't have the atoms from which to jump from one atom to the other. They would be missing that. But see, what these people do is do electricity without the atoms, and they just have electrons flowing through the space, which is even worse. No such monster. Okay? Now, magnetism, a different story, because magnetism does extend to extreme distances. Why? Because they are threads that are swinging around. For example, around the sun. Sun has a magnetic field that extends way out there beyond the Oort cloud. Okay, so the issue is that magnetism, yes. Electricity, no. Electricity is confined to the star, to what's happening in the sun. That electricity generates these threads that extend very far from the sun. Okay, that's what we're saying. That's why it's a magnetic universe, not an electric universe. But it doesn't rule out gravity, by the way. Okay, gravity is also important, but it's a different mechanism altogether. And so, what's the problem with all these electric universes? Universirs. They're known as thunderbolters, plasmoids. We have so many names for them. Okay, and the big problem is that they criticize the establishment. They say quantum is wrong, and so is general relativity with all its gravity and bending of space-time and so on. And they're right about that. It's the reasons that they're raising is for rejecting the establishment, which are not rational. And sometimes they invited me over there and say, why don't you join us since you're against establishment too? Yeah, but I'm not going to join cuckoo organization just to go against the establishment. I'll do it on my own, you know. I'll worry about this. I'll do my fighting all by myself if necessary. But the issue is that these people have borrowed the quantum atom. What was the quantum atom? We have an electron bead, right, going around the nucleus. That's the atom they're using. And electricity is the flow of beads. In fact, flow of beads originally from atom to atom. These people get rid of the atom of the nucleus as well, and now they only have all these little beads just flowing through space. And with that, they want to explain, you know, how this universe works. Obviously, they don't have a chance. It has, you know, their religion will die a natural death. Has no chance whatsoever in science. And over the years, we had these gentlemen, and these were probably the most prominent electricians. Maybe I'm leaving a couple out, and there were a lot more than these anyways, but these are some of the names that you will see people vouch for, and they put them up there as idols, and they say, oh, this is my hero, and et cetera, et cetera. And you go all the way to Oliver Heaviside, maybe. He's one of the first ones that comes out with, he was an electrician. And so, they come up with all these theories related to electricity. Nikola Tesla there, okay, he's also a famous guy for all these electricians. Walter Russell, some people vouch for him. You have Edward Leedskalnin, and he built a magnetic castle out there in Florida. And he's not exactly part of this group, but he is touted as a hero for lots of these electricians. They say, oh, look at all the stuff that he did. Yeah, the problem with Leedskalnin, he had no idea what he did. In other words, he built something with magnetism or using magnetism in some way, but he never understood what a magnetic field is. He could not explain, how the micro world works. Okay, he doesn't know what a magnetic field is, never did, and neither did any of these fellows. Now at the end there, you'll see Walter Thornhill and Wallace Thornhill, and he befriended me on Facebook a long time ago, and we never really talked, never really even sent a message or anything. In fact, he's still in my Facebook page as a friend, even though he died like 2 years ago. And likewise with his buddy, David Talbot, he befriended me, but we've never talked or exchanged ideas or anything. So it's one of those invisible friendships. Anyways, these are the heroes of the electricians. They raise these people as heroes. Some of them even put a fellow like Eric Dollard, and there's a couple more. There's several of these guys. What's the problem with them? Well, here, let's look at Tesla, who is probably the biggest hero of all that group. And Tesla says, if you want to find the secrets of the universe, think in terms of what? Energy, frequency, and vibration. And no, anyone using the word energy is an ignoramus. Okay, you can't use the word energy because energy is a word that should never be used in physics. Energy is a word of mathematics. Okay. In fact, let's look it up. Here it is. Here's the definition of energy. Okay. Ancient Greek meaning activity. Energy is not a noun. Energy is a verb. Activity. In fact, it's defined as the capacity. Okay. So it's a dynamic concept. Okay. So you can't use the word energy. What is it? It's a quantitative property. A conserved quantity. You get these from either the Wikipedia or the dictionary. Okay, these are the notions that they have. And what are the units of energy? Well, you have the joule, the kilowatt hour, calorie, right? And the one used by the accelerators, electron volts. They have giga electron volts, etc. So these are units of measure. Okay, these are values. So you cannot say you're going to transfer energy because you're not transferring a tree or a rock. What you're transferring is a number. And so they have the wrong language. And people like Tesla used to use that kind of language, and that's why he never made any sense. He didn't have any idea what he was talking about. A lot of people say, well, he took all these secrets to his tomb. Well, it's all those people who put more into it than there is there. I mean, if Tesla knew something, he should have published, should have made it public. Otherwise, he dies with his whatever secrets he had, and nobody ever heard of his secrets. Therefore, he had no secrets. Essentially, for all practical purposes, all his ideas were not there. Let alone that he took them to his grave. He had no ideas. He had no idea how this universe was run. But he was a tinkerer. He was a guy who was in the lab working with things and had a knack for saying, hey, I can use this for this, or he learned a lot by just doing electricity. But he never was able to explain. None of his explanations passed the minimum requirements of science. So he was not a scientist. Here you have another fellow that was on the list, Hannes Alfvén. And this guy is touted as a hero because he won a Nobel Prize. And so people say, oh, look, Hannes Alfvén, And he was electrician. He vouched for electricity also, and he was talking about all these filaments, those that you see there at the top, and they're mediated by what? Electricity. This is the notion he had, right? And he says space is filled with a network of currents. Absolutely not. Which transfer energy. What is energy? I thought energy was a number. How do you transfer energy? And momentum. You transfer motion. How do you transfer motion? Over large or very large distances. Again, Hannes had no idea whatsoever what he was talking about. And he got his Nobel for coming up with some explanation about electricity. But again, he had no explanations for how this universe works. Okay? So, these are not heroes of science. They're heroes of people who don't know anything about science, usually electricians, and people who think that everything out there is electricity. Okay? And again, they don't know what electricity is because they have this notion that electricity is the flowing of beads from atom to atom. And before you can do that, you have to specify what your atom looks like. You have to make a picture of your atom before you have anything in motion. And the problem that they have is they have this little bead, and you don't know why it doesn't fall to the nucleus or why it doesn't fly away. Until they can explain that, they don't have a model of the atom, let alone of electricity. And these people are talking about, electricity flowing through space when they don't know what electricity is. Okay, so this is the notion that they have, that people like Hannes Alfvén, that you have these galaxies and you have these electrons flowing through space. Now you can have atoms and make a case that the electrons are flowing from atom to atom. The problem with this is that space doesn't have atoms. You don't have between galaxies. You can't find gazillions of atoms, like covering all that space between them. That's the first problem. And so what they talk about is about the electrons flowing through space, which again is irrational. To say that electrons are just moving through space without any atoms, it's irrational, totally irrational. Aside from the fact that you would have to have a positive pole over there, using their language, and a negative pole over here, right? So the electrons flowing to the positive pole in one direction, would they flow in the other direction? I mean, from the positive to the negative? And then what is a positive pole in terms of stars? Is a star positive, another star negative? I mean, they have all kinds of problems aside from the fact that they don't know what electricity is. And here you have one fellow, his name again, Walt Thornhill, and he has this notion, or had this notion, right, that the universe is a bunch of light bulbs, the stars, and they're all connected, by some kind of invisible wire, for lack of a better word, and electricity flows from those wires from star to star, from light bulb to light bulb. That was his notion. Okay, we live in an electric world. All matter is electrical. Stars are simply electric lights strung along what? Invisible cosmic power line. Poor Walt. No, he had no clue whatsoever. But that was his notion. And here he talks a little in more detail. Let me put this over here. It says the electric force connects all matter in our local region of the universe. All matter in the local universe is connected in real time. How can they be connected? How can they be connected if, according to him, electricity is the flow of electron beads in one direction? So all these electron beads are discrete electron beads, every single one of them. One is not connected to the other electron bead. And you have these flow of marbles. How do you connect things with that? How do you pull, for example, with these electron beads, with these marbles? Quantum effects are not spooky, but due to near instantaneous resonant electrical matter interactions. Yeah, I mean, this is just waving of the magic wand. I mean, instantaneous? What do you mean instantaneous? I thought electricity flows. Okay, so you can't have a flow and instantaneous at the same time. They're a contradiction in terms. Instantaneous means, a given location, whereas flow means two or more locations. Electrons exchange energy instantly. Now, they don't exchange energy, and much less instantly, okay? We don't exchange energy because energy is not a physical object that you exchange, okay? With the nucleus and each other in an atom so that the energy sums to zero over each orbit. In other words, each atom is a complex resonant electrical system. All these notions are irrational, and again, it's because he was using Niels Bohr atom, the planetary atom. So he was saying, look, we have this bowling ball and this little bead that goes around it, and electricity to flow of the electron beads. And as long as you have an irrational model, of the atom, you're gonna end up with an irrational model of electricity. Guess what? Right? Okay, so here you have the theory from the people in the electric universe. Let me put this on there so you can see it. Okay. Says an atom is the basic unit of a chemical element. They're made up of tiny subatomic particles, including protons, neutrons, and electrons. Atoms are surrounded by one or more negative electrons. Again, this is the model they have. They have a planetary model. Electrons are a bit like non-committal partners. They can be easily separated from their host atoms. Again, he's thinking they're a little bead that just flies out. When electrons are emitted, the northern lights are born from these types of currents. So again, they think that currents are electron beads flowing in a given direction. Okay, whether we have atoms or not, I guess they don't mention that. They don't care. They just have these little beads. And with it, they form these filaments. These bursts and sheets are plasma filaments. Okay, you see that on the right. Okay, plasma is the most common of the four fundamental states of matter. Well, if plasma is a state, it's a concept, it's a category. Plasma is not a physical object, and they never learned this in the electric universe. It takes years to convince them that they have wrong language because they think that plasma, electricity, waves, ether in some cases, they think all these are physical objects. They are not. They are abstract concepts. And until these people understand, what they're talking about, until they use the proper language and define their terms, they cannot make their case. They don't understand that. They think that I'm doing word wizardry or word salad. They're saying, Bill, you're bringing semantic issues. Science is 150% semantics. You had better define the terms that you're going to use to present your theory. If you're going to talk about plasma and think of it and present it as a physical object when it ain't an object, well, we have a problem. We have a contradiction right there and then. And these people insist that plasma is a physical object. Why? Because they never define what an object is. And they say, well, now you're getting into grammar, and that's for English majors, and we don't want to get in that. We just want to do physics. Yeah, you can't do physics until you tell us what your atom looks like and what plasma really is. And plasma is a dynamic concept. What is plasma? The ionization. There's a process going on. It's not a static thing. You can't take a photograph of plasma because whatever you took a picture of is not plasma. Plasma has to be moving in order for it to be plasma. In other words, there has to be an ionization, constant ionization of an atom in order for you to have plasma. And they don't understand that. They don't understand that plasma is a process, not a thing. Okay? A running dog is not a dog. Okay? If the dog is running, the object is known as dog. What it's doing is running. And the same thing for a plasma. What the atom is doing is ionizing. Okay? The object is the atom. Okay? Gas in this case. If you ionize it, meaning according to the official version that they use, the electron is pulled away from the atom, then you have this constant pulling of electrons everywhere in the soup. That's a process. That's not a thing. The thing is when you stop all motion and you put all the electrons back to where they were. Okay? Then you can say that's a thing, an atom. But as long as the atoms are losing constantly their electrons, that's not a thing. That's a process. and it takes a long time for some will never get it, but it takes a long time for a plasmoid to understand that. Okay, so here's the definition of plasma. Okay, we can get it up there. There he goes. Plasma cosmology. What is plasma? It's the fourth state of matter. Again, if it's a state, it's a category, it's not a thing. But it is referred to as ionized gas. Yeah, ionized is a verb. Okay, in this case, it's an adjective, but I mean, ionized refers to the process of putting an electron in this case, right? So ionized gas is a process. You can't say, so you have to replace the term plasma with the term ionized gas. Ionized gas is not a physical object. Gas is an object, not ionized gas, okay? It takes a long time for these people to understand what I just said. Its atoms are divided into free-floating negative electrons, again, and this electron bead, and a positive ion. So they have these two balls, the little ball, which is the electron, and the big ball, which is the proton. That's what they think an atom looks like. An atom which has lost its electrons, lost its marbles. Plasma in space consists entirely of ions and electrons. Right. And the only way you can get ions and electrons is by a process. Okay, so again, plasma is not a thing, it's a thing in motion, meaning it's a concept, dynamic concept. Vast flows of charged particles. Charged particles. What are they talking about? They're talking about quantities. They're not talking about particles at all. Free-flowing electrons. A charged particle flow. So they have all these little flows, right, of electron beads, right? Or current, right? That's the name of it, right? Of charged particle flow. Produces a ring of magnetic fields around itself. So it produces a ring, but they don't know what are those rings? I mean, are we talking about a hula hoop? What are we talking about here? You know, and they just say it does. It is so. So they never identify what those rings are. They say there's these rings every time you have the flow of electron beads. Turns out there are no flow of electron beads and there are no rings. What you have is the threads of the ropes and of the atoms that are twirling around, right? In a spiraling manner all along the wire, because a wire is made out of iron atoms. We'll just go with the iron ones, and all these iron atoms are merged. Okay, so they form these long strips of merged atoms and molecules, essentially a long strip, and it twirls in situ, spiraling, right? And while it does so, it swings around all the threads, and those threads swinging around at 90 degrees to the flow of electricity, the direction of electricity, those threads form the so-called magnetic field. You can't do electricity without atoms. They don't understand this. They think they can do electricity without atoms, with little beads that just flow. Okay, and they have this notion that of the Christmas tree. Current flows into stars and power them like light bulbs. This is the notion they have. They think it's like a Christmas tree, although lights connected by some kind of wire, right? Charged particles move around and throughout plasma. Rings of magnetic fields can form around the electric current. This is called a plasma filament. So they have these filaments that they construct with these electron beads, right? Interconnected and perfectly woven, these filaments stretch across billions and billions of light years. Current flows through plasma filaments. So they think all these filaments that you see there, going from star to star, from galaxy to galaxy, are the flow of electron beads. That's what they say those filaments are. And the question is whether you can produce gravity with that. And they say, yes, you can, because positive attracts negative. See how easy it was? Whatever that positive is and whatever negative is. What's the problem with this? Well, the problem with this, one of the problems at least, is there are the vacuum levels in space. These are the general notions that we have of pressure or vacuum out there. On the moon, you have 10 to the minus 8 to 10 to the minus 12 torr. typically 10 to minus 11. In fact, NASA measured it at 2 times 10 to the minus 12 torr, okay? And in that region, you have approximately 200,000 particles per centimeter cube. Now, whether these numbers are ground in stone, probably not, but you get the picture. There are very few particles in 1 centimeter cube of vacuum, if you have 10 to the minus 12 torr. Okay, so you have very few particles relative to Earth. On Earth here you have 10 to the 19th in comparison. Here you have 10 to the minus 12. Okay, so you're talking about high vacuum, meaning there are very few particles per meter or centimeter cube. There you have interplanetary pressure, anywhere from 10 to the 6 to 10 to the 17 torr. That's minus, by the way. Interstellar, 10 to minus 16, 10 to 19 torr, minus 19 torr, and intergalactic pressure at 10 to the minus 25 torr. And so there are very few particles out there in space. Okay. Now the one on the moon we can more or less vouch for, because we have measured those. But the others are all calculated. They don't have an exact value for what's out there in space. But the ones on the moon, it gives you an idea how much the solar wind, how many particles they have. And they have very few particles per centimeter cube, because again, the solar wind is like 10 to the minus 12 torr. And so what's my argument? My argument, and I worked with vacuum for many years, you can't produce electricity in a vacuum. Let me repeat that, because I don't think the people at the Electric Universe are listening. You cannot produce electricity in a vacuum. You need atoms. You don't have atoms, you don't have electricity. What do? In the industry, in the semiconductor industry, you pump down a chamber. We used to pump it down to the minus 7 torr range. So we evacuated the chamber, left relatively few particles in there compared to room particles, right? And then immediately we have to fill it with, we usually filled it with argon, and we ionize the argon. And we use the argon as bullets, because now you can do something in there. You have electricity in there. If you don't put argon in there, and you only have minus 7 torr range, you have no electricity. You can't send electricity from, the cathode to the anode. You can't send electrons. You can't do anything. So far you have vacuum. And out there in space, when you have 10 to the minus 12, higher vacuum than what I work with, minus 12, maybe minus 16, or intergalactic, there are no particles per centimeter cube. There's nothing out there. And these people don't understand it. So they're talking about electricity flowing from one galaxy to another star, to another star, star to a planet, etc. There is no electricity out there in space. No electricity, okay? Because electricity requires atoms, and in order for there to be electricity between two stars, the whole path between the two stars has to be full of atoms. And that ain't the case. There are no atoms between any two stars. There's very few of them. And not enough to create electric flow. And so these people are out of their rocker when they talk about electricity flowing from star to star, let alone from galaxy to galaxy. So all those filaments that they see there, they say, oh, that's electricity flowing, electron beads flowing from one star to another, galaxy to another. Absolutely not. No way, no possibility. They need to study a minimum of what vacuum is. And once they realize that in a vacuum chamber, pumped down to the minus 7, you can't produce electricity, well then their whole theory goes down the drain. Okay? Because out there you have more than minus 7 torr, you have minus 12 torr. Minus 11 on the moon, solar wind is around minus 12, even lower, and that's how it's been measured. But certainly it doesn't go above minus 7, maybe minus 6 at the most, but you can't produce electricity at minus 6 either. So there can't be any electricity between stars. Impossible, because there's no matter out there to convey the electricity. Okay? I don't know how else to explain it to these people. Okay, and so what are some of these electric universes come up with? Well, here's Sainsbury. He's the guy who came up with the notion that gravity is electricity. And how does he do it? Well, he says negative attracts positive. And so he goes through this rigmarole where he says, well, all the electron beads pile up on one side of the planet and on the other side of the star, and that's how the star attracts a planet like the Earth. Okay, so this was the general notion. I'm not going to go through all the little details of Sainsbury's theory because I think it's bunk. Okay, and here you have another version that he had. Again, it shows that a planet like the Earth has all these positive charges, right, at the surface. And again, he's talking about math. He's not talking about physics. And he says the sun has all these negative ones at its surface. And because of that, positive attracts negative. And now you have, this force that attracts them. What is he talking about? Is he talking about physics? He's talking about math. And he's got his math wrong because it's waving, hand waving. He's just saying that it is so, okay? And that there's this electrical force that is really representing gravity, okay? So what can I say? These people are not even close. The electric universe is total nonsense, poppycock. None of it survives, none of it. Partly because they have the wrong atom, okay? That's the first one. They're using Bohr's atom. Part of it has to do with the fact that they're trying to do classical physics by relying on quantum physics. In other words, they're relying on the quantum models to do classical physics. And the quantum folk, they say, look, you can't do that because we've already established that you cannot do classical physics with quantum physics. Quantum has special rules in which you have all these magical properties which they push aside, calling them dualities or whatever, and paradoxes, right? And they live with that. And the people in the electricians, they want to do physics, the old-fashioned way, like 19th century way. They said we lost our way. We did lose our way, no doubt about that. But what are they doing? They're using the atom that quantum is feeding into their mouths. And so, you can't do that. And then the other problem with the electric universe, again, there's vacuum out there in space. There are no atoms, so there is no electricity out there. Electricity is within the sun. Yeah, there is electricity within the sun, but it creates a magnetic field that extends very, very, very far out there. So magnetic field, is a factor in the universe. Electricity is not. Electricity is local. Okay? And so that's all I can tell you. Okay, again, it's like, you have an electric wire and the electricity flows through the wire. It's local in the sense. It's contained within the wire, within the sheath, right? But the magnetic field extends way out there. And if you compare the size of the magnetic field compared to the size of the electricity flowing, magnetic field is much, much, much bigger than the electricity flowing through a wire. Okay? In fact, you can do that with a magnet as well because that also has electricity in there. There's an electrical current in there, but it's the magnetic field which extends way out there. And that does not overrule gravity. Gravity is still a mass-related phenomenon. It has absolutely nothing to do with the magnetism of a sun, of a star like the sun. Okay, so let's look at the photon now. Let's get into the photon. What is a photon? Well, photon could be a little particle, maybe a little ball like that. Right? That's a photon. Right? But that's one version of the photon. The other version is the wave, famous transverse wave. And so all these fellows out there in the 19th century primarily, right? They came up with this notion of the electromagnetic wave, the transverse wave, right? And what you're staring at is, a lot of vectors that form two fields, the blue and the red field, right? And the vectors are numbers. All we have is quantities there. And what are the fields? Also a bunch of numbers. They're a value at each point in space. That's the definition of a field. So there is no physical object called a field. Okay? But they treat it as a physical object. They represent it with this abstraction full of arrows and lines. And that's a mathematical representation. In other words, they're putting a physical thingy there, something that you can see, but they're representing really numbers. What you're staring at is numbers. And what we're saying is what they've been pondering all these years is a rope-like mediator, agent. And what you have is two twined threads. That's what they've been describing all these years. Okay, so, and you can see the difference. One is a mathematical concept, the other one is a physical object. Okay? But what did that do to the particle? Well, you had Max Planck at the beginning of the 20th century. He comes up and reintroduces the particle. Throughout the 19th century, it was all waves. But now, at the beginning of the turn of the century, they introduce the particle again. They say, oh, but we have energy comes in discrete packages, and so, or packages, right? And so they have the elongated wave and they have the discrete particle. And what do you do with that now? You have all these little dots, these particles, and you have also the wave. So which is light? Is light a bunch of particles strung out, or is it a wave that is a mathematical concept, right? That elongated mathematical concept, you could say, a bunch of numbers, that's all they are. And in between, about 1926, maybe it was 1925, you have Heisenberg. He comes up with this uncertainty principle, and he says some pairs of observable properties like position and momentum cannot be simultaneously measured with perfect accuracy. The more precisely one property is measured, the less precisely the other can be known. And what he's saying is when you have, position, which is a static concept, like, there's your ball right there, standing still, you don't have motion. And when you have motion, you don't have position. That's all he said. So the more you know about position of a particle, the less you know about its movement, because it's not moving. And the more you know about the movement, the momentum, right, the less you know about its position because, it's moving. It took a mathematician to come up with all that stuff, right? He had an equation for it. Jesus. No wonder he deserved his Nobel Prize. He was able to explain it, to describe it, really, mathematically. But what's the issue? They have all these dualities, and they extrapolated that to light. Okay? And so here we have the famous complementary principle by Niels Bohr, and he essentially extrapolated this paradox to light. It says quantum objects like electrons or photons can exhibit both wave-like and particle-like behavior. Again, this duality, this complementarity as they call it. Experiments can reveal either the wave or the particle nature, but not both simultaneously. The act of measurement influences the behavior of the measured object, making it impossible to have a single complete description independent of the experimental context. Bohr's complementarity principle suggests that seemingly contradictory aspects of reality can be understood as complementary rather than mutually exclusive. And here's the punchline. It highlights the probabilistic nature of quantum phenomena and the limitations of classical physics in describing the subatomic world. So classical physics cannot describe, according to the quantum folk, the subatomic world. That's why they abandoned classical physics. But what they should have abandoned, instead of classical physics, they should have abandoned the particle hypothesis. You cannot explain the micro world, the subatomic world, with particles, with discrete particles. That was the whole problem. They should have gotten rid of the particle hypothesis completely. They never did. They incorporated it instead and mixed it with the wave, complementarity. And so here you have the result. You have light is both a particle and a wave, or depending on how you measure, it could be one or the other depending on the experiment. And you see the particles there, the yellow ones going right through the wave. So I guess depending on the experiment, you get rid of the wave or you get rid of the particles, the yellow particles. And what survives is the remainder. Okay, so you get rid of the particles, you have waves. You get rid of the waves, you get particles. That's their argument. What have they explained? Nothing. They don't understand squat about the invisible world of Mother Nature. And yeah, here you have the quantum wave packet. You have waves essentially mathematized by Maxwell. Then you have Planck, and he comes up with his notion of the discrete particle, the discrete packet of energy, right? That's what there's going to be, what they're going to call a particle, even though energy is just a number. And even today you have Penrose, who in one of his books illustrates the wave packet, which is a little curlicue, corkscrew with an arrow going right through it. Ridiculous completely, all three of them, okay? Because the wave is a bunch of numbers. The particles are also a bunch of numbers because they're talking about packets of energy. And a wave packet shouldn't even be mentioned. It's just ridiculous. But this is what Penrose put in his book. Yeah. Okay, and so what does the establishment think of complementarity? Well, we'll let Sabine Hossenfelder tell us. Listen to her, okay? Here goes.
We can reduce the intensity of the laser light until there are only single quanta of light, individual photons traveling towards the slits. And the odd thing is now that the photons, which are particles, build up an interference pattern one by one. This seems to show that a single photon also behaves like a wave. It must go through both slits and interfere with itself. That light behaves both as a particle and a wave is often called complementarity. So far so good. Not that it makes sense, but we've gotten used to it not making sense.
It doesn't make sense, but the mathematicians have gotten used to not making sense. Or like Neil Tyson says, Father Universe has no obligation to make sense to you. I love that. And he repeats it every show he gets into. Okay, but so we have this complementarity. Now they've introduced a new factor, and this was about a couple years ago at least. They introduced what is known as dark photons. Very scary stuff. If you thought the photon was scary because it's got this duality, wait till you hear about dark photons. And this is how it's illustrated. If you have the slit experiment, you have the light photons, which are the ones you will see on the screen, and the dark fringes in between them. Those, according to a new version, right, the newest version, are dark photons. And whereas light photons have no mass, dark photons are very, very massive. Why? Because they're going to try to explain dark matter with these dark photons. In other words, they're not going to say that dark matter is made of dark photons. They're going to associate the light photons with the dark matter via dark photons. Okay, that's the plan, that's the scheme, right? So here's a definition or a description of what a dark photon is. The regular photon is massless. The other one, the dark photon, is not only dark, but it's heavy. Okay, dark photons are a hypothetical type of particle, also known as hidden photons. They're hidden. Everything's invisible, right? That are theorized to be a force carrier. They carry forces, like on their back, they always carry forces. Similar to the photon of electromagnetism, but potentially linked to dark matter. So now they're going to try to explain this dark matter, which they think keeps the galaxy together, right? Because dark matter is this invisible mass, these kilograms that they sprinkle on the outside of a galaxy to make the stars on the outside travel as fast or faster than the ones on the inside. And the only way you can produce that through mass is by sprinkling mass on the outside and not on the inside. Because if you sprinkle that mass between the Earth and the Moon, well, both Newton and Einstein die a sudden death. Gravity would not work the way it works today. So they had to sprinkle it on the outside. Why? all this dark matter is on the outside and nobody knows. They're trying to figure that out. But here we have the savior, which is the dark photon. So as they are thought to be massive. Okay, so massless versus massive now, right? Dark photons are typically assumed to have a mass unlike the massless photon of electromagnetism. They are suggested to be the mediators, force carriers, right, of a new dark force. We have all these dark forces. Everything is dark in mathematical physics. And dark matter, dark energy, dark photons, dark forces, potentially connecting the dark matter sector to the visible universe. So they're inventing these angels, right? And they're always dark angels. I guess they're evil, I would think. I don't know. And here we continue, and it shows you how they're trying to connect it to dark matter. It says, dark photons provide a bridge for interacting with dark matter particles. See, they think that dark matter is made of particles. Particles we can't see. They're all, we have no ability to see them. And I'm sure that if we sent a spaceship out there, we would not be able to touch them either, right? This bridge is formed through a mechanism called kinetic mixing, where dark photons can interact with regular photons, right? Creating a non-gravitational window into the dark sector. So we have a gravitational region and a non-gravitational region, right? And they're going to use this to relate the dark photons to the dark matter. While not a dark matter candidate themselves, dark photons could be force carriers within the dark sector, right? Mediated interactions between dark matter particles. Okay, so the dark matter particles that form, the dark matter, they're mediated. The mediator between them are these dark photons. So we have invisible dark matter particles mediated by invisible dark photons. Okay, it's all dark. It's all very dark in that region. So that's why we can't see it. Right? Very simple. Well, let me tell you what I've done. And hopefully they'll give me a Nobel Prize for this. Okay, I think I deserve it. I really do. So. Here you have the standard electromagnetic wave, right? And what I'm proposing, I'm inventing the dark waves, okay? Now, isn't that original? They have dark photons. I'm saying, hey, they're dark waves, okay? So we can compare them now. Here you can see the comparison of these two, the dark ones and the light ones. Okay, there it is.